Okay, so now we're going to remove the confederation completely, and we're going to replace with a route reflector with peerings to all of the different PEs. We're going to have two clusters. Cluster 1 is going to be the right hand side of the board, cluster 2 is going to be the left. Now, it's actually quite encouraging that you can remove the confederation, replace it with a route reflector, and really not have to change anything at all, because it really tells you that those two things really are doing the same job. However, we do have a group IBGP, and we've got it configured with some confederation settings and some different peers. So there's two ways to do this. The first thing that we're going to have to do no matter what is to delete routing options confederation. We'll need that everywhere. And then if we delete the BGP group IBGP and CBGP, obviously CBGP needs to go. But if we delete IBGP, then we have to make very sure that we put the export next hop self back on the new IBGP group when it's created. However, you could go and you could edit, you could take out the different neighbors. Okay, then there's a couple of things that we have to add. On router 1 and router 2, we've got two interfaces. It's .206 on router 1, it's 207 on router 2, different IP addresses, and that's just the data plane for the route reflector. Now ISIS is on everywhere, all the interfaces, so the ISIS is good to go. Then of course we need to set the autonomous system in each of the routers. That's really the same part as removing the confederation number, put in the AS number. Okay, so now each of the peers up to the route reflector. It's pretty simple. Set protocol BGP group IBGP, export NHS, very important on routers, well, all of them except for 1, 2 and 4. If you remember, 4 has no external peers and 1 and 2 have the this shared interface to the Internet Exchange. So export NHS, type internal, local address and the local loopback of the router, import routing to black hole, neighbor of the route reflector here at .41, got the authentication on, and now we have another BFD liveliness. So this one is on BGP. So we'll end up with 3. We've got BFD liveliness detection on the ISIS itself with ISIS timers. We've then got BFD liveliness detection here on the BGP, and we'll end up with BFD liveliness detection on the OAM on the MPLS circuit. So here we've got a minimum timer here, minimum interval of 3 seconds. And the thing we have to bear in mind here is that BFD is using port 4784. We really do need to allow that. Then later when we're looking at the MPLS, the BFD actually uses an LSP ping to work, and that's, I believe, 3503 that will also need allowing through the firewall filter. And also that would also need to happen on the route reflector if we had the firewall filter on the route reflector as well. Okay, so the last part of this is configuring the route reflector. Obviously it needs the two interfaces bringing live to router 1 and router 2, family ISO for the ISIS to operate, and of course we're going to need an ISO address because of course this is integrated ISIS, it's carrying IP but it's using ISO to do it. So it's going to need an address, going to need that family because it's the encapsulation on the interface, and of course it needs to be in the correct area. Then it needs the autonomous system number, and here we have the two clusters. If you have one cluster, you still have to define it. These are the names of the groups. Here are the cluster definitions, cluster 0.1, 0.2. The appropriate BFD liveliness detection on the other end of the lines. We've got the same authentications. We've got the local address of 541. And then we've got the neighbours. These obviously are on different lines. 172.35.1, which is router 1.678. And then on cluster 2, the remaining ones, which would be 2, 3, 4 and 5. Okay, so the only other thing that we will need is set protocol BGP disable 4-byte AS, because we're emulating on the route reflector a system that can't understand a 4-byte AS. And in that case, any peer AS that has 4 bytes is going to need to be set to 23456, and then BGP is going to create an extra object, and it will pick up the v4 path after the AS that can't understand it. And the other thing we have to bear in mind is that, of course, we're no longer running the deprecated version of mapped v4 v6 packets, so we may well need the set system allow v4 map packets.